invitation and introduction, Jane, and this is really a great opportunity for me. It's exciting to be on Roosevelt Island in general, but I was one of the first faculty to be hired at Cornell Tech when it was just in temporary space in the Google building in Chelsea. And it just seemed like a dream that we would be here one day. So it's still, I just have to pinch myself when I'm lecturing in this hall just to believe that this is actually happening. Because when we were in the Google building, it was just cramped little space, no real classrooms. So it's just exciting to have this opportunity. So Jane pretty much went over this already in the introduction. And one of the things she brought up was that I came here from UC San Diego, and I'll actually be explaining a little bit of that story on the personal side of how that took place. So one of the things that wasn't included in my biography, as Jane read it, is augmented reality. So that's actually a new area that I'm getting into. I picked a sampling of projects that I'll describe. I'll just give a brief, non-technical survey of these different research directions. And these all involve some mix of computer vision and machine learning. And those are also the courses I teach here. In fact, I teach an applied machine learning class in this room from this exact spot. I just turned this on as a habit. Normally I'd be writing equations here, but I'll spare you today. So I picked a couple projects. The first one is something that has to do with fine-grained category recognition. So what is that? This is part of a project called Visitpedia. And some of you have heard about things like artificial intelligence, computer vision, image recognition, and so on. And it certainly made huge advances in the last decade or so. It definitely, AI is very good at telling you something like there's a bird in this image, or there is a face in this image. Where it does not do so well is the so-called fine-grained problem. And that's something like, you know it's a bird, you don't need the computer to tell you that part. The question is, what species of bird is it? Or perhaps you know the species and you'd like to know what type of bill the bird has, or what is the scientific name for the type of plumage that it has. So these are things that involve expertise. And Visitpedia is about capturing and sharing visual expertise. Some people possess a great deal of visual expertise, and there are lots of other people out there who would like to learn things about collections of images that they have. Or you see an interesting object during a hike on the beach, you just like to know what it is. If you could get that photo to the right person, you could get a great answer. But what do we do until that type of thing is possible? So one of the ideas behind Visitpedia is that lots of people have hobbies or beyond hobbies that motivate them to collect large databases of photos and share them with other people. And you get known within your community that you're very good at categorizing certain things. It could be lemurs, ring-tailed lemurs, or it could be certain types of biplanes. And it's just human nature that we find these specific categories very interesting. And if you step right outside of that, it's not so interesting. And you find out at family reunions, like people forget exactly what your hobby was, and they say, oh, I heard about this new bird that was sighted in this area. And you say, oh, I'm not actually into birds, I'm into butterflies. Oh, sorry, you know. So we all have our hobbies, and Visitpedia builds on that kind of personal interest. Now, another principle behind Visitpedia is that categorizing, there's this complementarity between what humans can do easily and what machines can do easily. So I think most people here could look at that example on the left and answer yes or no. Is that a chair? Is that an airplane? Is that a bicycle? So that is called a basic level categorization problem, also known as an entry level categorization problem. So probably a child of age 3 or so could look at that and identify it. The thing that's hard, unless you happen to be a bird expert, is to say exactly what species of bird that is in the middle. So if you're just given that as a pop quiz, is it an indigo bunting? Is it a finch? That's hard. Now, what Visitpedia does is it breaks it down into what we call visual 20 questions. So you, instead of going straight for guessing the species of the bird, you would answer simpler questions that just require generic knowledge, like is the belly blue, is the bill shaped like a wedge, and so forth. So this brings us to this idea, this so-called visual 20 questions, where the human and the machine work together. So you take the image of the bird and you put it into this flow chart here, and the first block is computer vision. So that is the totality of the field that I research. It's all represented by that block called computer vision. And that block, in an ideal world, would solve the problem. You would put in the image of the bird, and you would get out that little bar chart down there. For those of you that know about probability, it's something called a posterior probability. If you haven't heard of that, let's just say that you would like that box that says computer vision to pop out a little bar chart that's very high over one species of bird and really small over the others. That would tell you that the computer is confident that it's a particular species of bird and that the rest have very low probability. Well, despite all the big advances in computer vision, you don't always get it right with the latest artificial intelligence algorithms, and that's where the human user comes in. You still have eyes, you have a visual system, you can look at the bird and help the computer narrow down the identification. So the idea with this visual 20 questions system is that we have a large collection of questions about attributes and parts that we can push back to the user. So we take the image, run it through computer vision, get some idea of what species of birds there are, and then to disambiguate, the computer reaches into this bag of possible questions to do something called maximizing the expected information gain. We want to pick questions that maximize information, and it's tuned to how the computer performed on trying to identify that image by itself. So for this particular image, it maybe narrowed it down to 3 different species, and the computer automatically suggests this question: is the belly black? So you can look at it and say no, and then one more question: is the bill hooked? You say yes, and then it gets it. All right. So this is the spirit. It doesn't literally go to 20 questions. Usually it stops after 1 or 2. And the system gets smarter as you use it, and increasingly it's actually getting it right the first time. But the human and the machine are sort of having a little conversation or game to get there. Now, this brings us to something that happened in our field in 2012, and this is just a little kind of, at this point, I guess, a history lesson of what's happening in artificial intelligence. This incredibly influential thing called deep learning exploded onto the scene in 2012. So this Visitpedia project got started around 2008 to 2010. And I came up with this little nickname called antediluvian. It's a play on the word antediluvian. So who knows what antediluvian means? It's a biblical term. Before the flood, okay? So antediluvian means before the flood of deep learning papers. So this deep learning thing was so big, it really just washed over the entire field, and all the old methods just got thrown out. And these new methods that are based on something called neural networks became extremely popular. They had been popular before and went into the doghouse. They'd been popular before even that, and so it's sort of a cyclical thing. But when we got started with Visitpedia, this block called computer vision was not based on deep learning. And frankly, it didn't work that well. You needed the humans a lot. Then came this deep learning revolution, and we started using these so-called deep convolutional neural networks. And don't worry about the details of this diagram, but they look at the pixels, the colors, the textures, the arrangements of the shapes, and so forth. And basically what you do is you feed it hundreds or maybe thousands of examples of each thing that you'd like to recognize. So in this case, we want to recognize species of birds. You give the system a whole lot of training data, and you train these so-called deep neural networks, coercing them to output that kind of bar graph I told you about before. where that high bar means it knows that this is a particular type of finch. So this brings me to what actually enticed me to leave California. So what happened was I started working on Visitpedia in a pretty abstract way. It was a collaboration between UCSD and Caltech. So that's La Jolla and Pasadena, for those of you that know Southern California. And when we started, we knew that Visitpedia was about capturing and sharing visual information, and that we would tap into these communities of expertise. But what community to choose? There's so many groups of people that are enthusiastic about coin collecting, stamp collecting, sneakers, butterflies, and so forth. But then I remembered, because I have two older siblings that went to Cornell a long time ago, that there was this famous lab of ornithology at Cornell. It's in a place called Sapsucker Woods outside of Ithaca. And it's a world famous place for studying birds and wildlife in general. And I thought, well, that would be an amazing group to collaborate with. And I checked, and they were still in existence. And it's not that I'm a birder myself, I just found it pragmatically very interesting that there would be a research institute of that type that would have a very large group of followers and enthusiasts who could help test out and train a system like this. So we actually got started by building our own little data set, which I haven't shown a picture of. It's very meager compared to this one. It was called the Caltech UCSD 200 birds data set. And frankly, it stunk. It was a really bad data set. We didn't know where to look. We knew that the Lab of O existed at Cornell, but we, like typical computer scientists, we just wrote a script, found a website that had some kind of bird classification app, downloaded the data, picked 200 species of birds, and we started doing experiments with it. We wrote a couple papers, and at some point, someone at the Cornell Lab of Ornithology found the papers. And this lab is such a big deal, I can't really overstate it. And I can say it objectively because I wasn't affiliated with Cornell at the time. Someone there found the paper, and they called me and said, "You may visit us." Okay? So you don't call the lab and say, "We want to collaborate." You just send out a bat signal of some sort, and then they sense that you have exceeded some threshold of interestingness, and then they say, "Okay, you may visit." And so I did, and I presented what we were doing, and they said, "We like what you're doing. Your data is horrible, but your methods are interesting. We will work with you on what would become the NA Birds," we now call it NA Birds 700 data set. This is a world-class data set curated by members, volunteers actually, of the Cornell Lab of Ornithology and vetted by experts there. And that became our first experience working directly with a community to curate this kind of data and train machine learning algorithms. The way it works in practice, and then how that brought me to Cornell. Well, so when they invited me to visit, I knew that there were computer vision researchers already at Cornell in Ithaca, and I felt a little awkward coming all the way from California to meet the Lab of O people when there were computer vision people just down the street. So I made sure to meet Dan Huttenlocher, Raman Zabi, Noah Snavely, and I said, "Just want to let you know I'm meeting these people, not trying to step on your toes." And they said, "Oh, actually, we're delighted because they're so interested in collaborating, but none of us do that kind of thing." And so it was actually a relief. And so I continued the collaboration. And then at some point, Dan said, "By the way, we're putting in a bid. This is a crazy thing, but we're putting in a bid for a new campus in New York City. And if we were to get it, would you want to participate in some way? Just visit for a semester or something." And it sounded so far-fetched. And everyone in California thought Stanford was going to win that anyway. And I just said, "Sure, I'll come for a semester." And then I got a call from him a year later, and he said, "We got it. So you're coming, right?" So that was 2013, and so I was one of the first two faculty to join.